Hey guys, this is, I believe, L25, and I don't know if you can see my other tab here, but I have all of this open. I'll link this URL down below in the description, but this should be all you need. So far, going through his video, which was super helpful when determining what's L and D. I used this alongside him, trying to figure out what do I have to change and stuff. So I think this is really beneficial. But let's start. So I'll go back and forth, but I actually had this printed out because I like to have it in front of me and I don't like to go back and forth. If you don't have a printer or anything, you just draw it. It's just for me, it's really hard for me to focus and go back and forth and try to see how many carbons, go back to it, draw the carbons, So I got my phenyl group, and then I'm going to add this on top, and then this is going to be an NH3, as he mentioned in his video. So that's also one thing that we're going to change, because in his video he wants us to put a positive nitrogen and a negative oxygen. So this is going to be deprotonated, and this is going to be protonated, and that goes for all of them. So let's see where I was. Okay, I was about to add my oxygen double bonded, and then my OH group that I will change and deprotonate. Once I add the hydrogens, I'll deprotonate it, and then I'll go ahead and add my hydrogens, and I'll use my heterolytic function to remove this and then attach it to the nitrogen. So that gives this oxygen a negative charge. It's got 1, 2, 3, 4, 5, 6, 7. And then this has got 1, 2, 3, 4, so a positive charge. That's exactly what we want to see. And then lastly, I'll roll this around to give kind of like a Fischer projection of sorts. So we see how he mentioned it's a bow tie. So these are both facing up. So when we have our L, we want our nitrogen on the left side. Let me see. I'm pretty sure. Yeah, okay, we want it on the left side. And then just because we want the L to be an S configuration, and if we do that, we see that we have our highest priority here, our second on the top, and then our third on the bottom, which gives us R, but the hydrogen is facing forward, so that actually gives us an S. Lastly, I'm not sure if these hydrogens need to go up. Let's just go ahead and turn this in and see what happens. And then, of course, you always just want to make sure that your bonds look good. I think they look good, so let's try it. We're going to put 6 because that ring has got 1, 2, 3, 4, 5, 6. All right. Okay, we're going to enter the name of this. So we see a phenyl group. We have our, so I'm going to turn it around like this so that I can see my nitrogen group. We have our carboxylate group. So I'm going to go over here and I'm going to go and look for something like that. So this one catches my eye, tyrosine. Let's see, that's the only phenyl group I see. We already did this one, but as we can see when we go back, we have an OH group attached at the end. So it's looking like tyrosine. So let's go back to it, and I've got it printed out, so I'll just double check that we have the right one. So we've got our phenyl group, and then 2 carbons with a nitrogen, another carbon, and yeah, it looks like that's the right one. And we can just do the configuration, but I can already see that this is on the left side, so it's going to be L, because we got our first priority, second, and then this R group is our third, so R, and then this forward hydrogen makes it S, so this would be L. So I'll put L dash, ooh, I think we want to capitalize it. If not, this will be a good learning lesson. So tyrosine. All right, let's try it out. Okay, good learning lesson. Do not capitalize. I find it a habit of mine writing in my notebook. I'm always capitalizing like the first word and I need to stop. Okay, so we see two rings, a 6-member ring and a 5-member ring of furan and the pyranos that he was talking about in class. So we can go over here and let's see, I see tryptophan. That's the only one that pops out at me because it's got that 5-member ring and the 6-member ring. I don't see anything like that, so I'm going to go back over here and now I'm going to look at my sheet. Okay, so we've got 5-member ring, 6-member ring, 1, 2, NH attached at the 2, 3. I mean, if you're counting this way, it wouldn't be. I was counting from here, just so you guys know. Okay, so that looks good. And then when we have them forward, I see that my NH group is, or my ammonium group is on the right side, so I know that this is going to be D. If we do the configuration, we're going to get 1, 2, and 3. It's going to be counterclockwise S, but we switch it around because the hydrogen's facing forward, so this would actually be R. So R is associated with D, and S is associated with L, unless you're dealing with, I believe, cysteine. Yes, cysteine. That one's a little, that's like the exception. So I'll put D, and then we've established that this was tryptophan. So tryptophan. TRYP2. Okay, I didn't capitalize this time, so hopefully that will be good. Let's try it out. Awesome. Okay, I'm gonna turn around this way. I already see we have L because on the left side, and if we want to do a configuration 1, 2, 3 R, which it changes to S because my hydrogen is facing forward, and then it's followed by 1, 2, 3 carbons and carbonyl group, and then this nitrogen group. So let's go back to the little chart. I'm going to be looking for 1, 2, 3, then OH, and an NH2 at the end. So this one looks kind of like it. 1, 2, so no. Let me see if the counting starts at 1. Okay, so I'll skip this alpha carbon and I'll start counting 1, 2, 3. The third carbon from the alpha carbon will have a double bonded O, or the carbonyl. Let's look for something with NH2 hanging off of there. So I see this one. So I'm going to count from the alpha carbon. Or I'm not going to count the alpha carbon, I'll count after. So 1, 2, 3. That's where the OH, or the O is attached, and then that's where the N should be attached. Yep. So that's how I matched it up. I start at the alpha carbon. I don't count it though, and I do 1, 2, 3. 3 the O double bonded, and 3 the NH double or single bonded. So alpha carbon, 1, 2, 3. Just because these might be kind of confusing, like if you're counting at the alpha carbon and you're counting the alpha carbon, you're going to be doing 1, 2, 3, and that would look like asparagine, but it's actually glutamine. So we already established that it's L because on the left side, oops, no capitalization. Get out of the habit. Glutamine, that looks good, feels good. Oh gosh. Okay. I hate being confident because that's when like it really brings you down, you know. Okay, I'm gonna arrange this. So I already see it's L. I've got my Fischer projection like this, and I have my nitrogen on the left side. So put L dash. And then I have my alpha carbon, and then I have just one carbon with an OH group and a methyl. So let's go back. We're gonna look for a little one. Okay. So let's see. I see a little one here, but that looks too little. So I'm gonna look for a bigger one. This is too small too because I need an OH group. Right? OH, yeah. So let's continue on. These are definitely not because they have sulfurs. This has a nitrogen group. I'm going to keep going down and look for something that resembles what I need. Okay, I see serine. So starting at the alpha carbon, we have just an OH group. We don't have a methyl, and it's not attached to that methyl, so I need a methyl. Okay, I see this one. This is like this one, but it has a methyl. So we have the alpha carbon, and then we only have one with the OH and a carbon attached. Yeah, alpha and then one. So let me double check. We have alpha, oops, threonine. I'm looking at that one. So we have alpha and then one. So I'm confident it's threonine. So I'm gonna just type like that. We already established it was L. And let's double check with my paper right in front of me. But yeah, it looks decent. We see our NH group is opposite of our OH group, so let's try it out. Okay. L-serine. So I'll show you over here. So we have serine. So this is one I was looking at before, but it was missing the methyl group. So we're basically going to draw the same thing, but we won't have that methyl. And of course, I'm going to be looking at my paper instead because it's much easier to see just in front of you. Okay, I'm going to replace this with an O, this with an O, and then we had an OH group. On the other one, on threonine, we had the methyl group, but here we just have a hydrogen. And then my nitrogen, I can't forget that. And everything else. And then lastly, this is L. And I'm actually going to, let's just fix this. Before I forget, I'll deprotonate my oxygen, and then I will protonate my nitrogen. Let me roll this. We don't have to worry about the second chiral center because there is none. So we've got it on the left side, our nitrogen, which means that it is in fact L-serine. But I look on here. Okay, yeah, these should be on the same side according to this picture. So we see them, there would be, if you can imagine, a hydrogen. So this should be good. Let's try it out. If not, I'll. Okay, awesome. Okay, let's see where to begin. So this is the top of my molecule that I like to look at and then start counting from that alpha carbon. So I've got the alpha carbon here, and let me go and turn this around so we can see the bow tie. Here, I'll show you like how I've been doing normally. So we see the bow tie and we see the in group on the right side. So I'll just go ahead and put D. So I have that already. Okay, now I'll zoom in and counting from this is the alpha carbon. I'm gonna count 1, 2, 3. At the third carbon, I have this little mess of nitrogens. So let's go to our other page. And I'm looking for stuff that has a bunch of nitrogens hanging off. I don't think, oh, look, arginine. Okay, so we counted, and this is the alpha carbon, 1, 2, 3, arginine. So we've got it. Arginine. Looks good. I don't know what happens if you put like D-arg, you know, like the abbreviation, but feel free to try it. I am not going to, but yeah, it might work. Okay, so I've got my Fischer projection just like this, and I have my nitrogen on the right side, so I can go ahead and put D, And in case it's a little confusing, just remember, like when you're looking at it, they both have to be facing up. So if I had it like this, I can't say, oh, this is on the left side, so it's L, because it'd be wrong because they're both facing back. So whenever you do that, you just want to make sure they're both facing up. And then we see now that they're both facing up, this is on the right side. So it makes it D. Okay, and now I'm gonna count from my alpha carbon. And I've got 1, 2, 3. So I've got 3 right here, and then at the first position I have 1. So these are a little trickier because it doesn't have any OH groups or anything, so those are easier to see in this page, but when it has just methyls it's a little hard, or just carbons it's a little hard, so let's try to find a chain. So we have this, but we would actually need another carbon. 1, 2, so let's find, ooh, like right here. Let's see, counting from the alpha carbon. I don't count the alpha, I'll count 1, 2, 3, but I think the methyl should have been at the first one, so let me double check. Yeah, so that would not be it either. Let's keep going. Ooh, isoleucine. 1, we've got that methyl at the 1 position. 1, 2, 3. So we've got 3 counting from the alpha. So we've got an alpha here, we're not counting it. 1, 2, 3 with a methyl at the 3. I mean at the 1 position from where I'm counting. And we've got 1, 2, 3, and the methyl at the 1 position. So I believe this would be it. I do declare. Isoleucine, yeah, I think I spelled it right. If not, the system will definitely tell me. Okay. Asparagine, so I'm gonna look, I see arginine, here it is down here. So I just wanted you guys to get a little picture of it, but I have it printed out, so I'll go ahead and draw it out. NH2. And guys, however you want to draw it, like if you feel comfortable drawing each thing individually, do that. I like drawing everything like this and then adding everything at the end. I know it can be confusing for some people, but this is just the way things work out for me in my head. Asparagine is okay. So I want to make sure I have the right amount of carbons. I got my double bonded, or my carbonyl, my NH2, and then 1 carbon here, 1 carbon here, 1 carbon here. This whole thing, NH2, which will then become NH3, add my hydrogens, hit arrange, and then I'm going to use my heterolytic function to deprotonate this oxygen and protonate this nitrogen. I don't do it like to this one because this is actually just attached to a carbonyl group. I want to do it next the one that we're using for like the alpha-Ammonium, you know. So I'm gonna roll this around so that I have my Fischer projection. Roll it a little bit, and I see that this ends up being on the right side. So I have, I drew D, so I'm gonna press mirror. Okay, now it's on the left side, so this should be L. And then I'm going to look, I don't see any more chiral centers because we see this carbon has duplicates of hydrogens. This carbon has doesn't have the right amount of bonds, so this should be good. If not, then I don't know. Let's try it. Awesome. Okay, last one, aspartic acid. So I see it right over here. So that's all we're gonna draw. Okay, I've got my carbonyl carboxylic acid actually. And then this is gonna be a nitrogen down here, and then I have another one. Okay, I'm gonna change a bunch of things to oxygen and nitrogen. And I see this is closer to the side, so I'm going to, this is the alpha carbon for this. So this would actually be the beta carbon for this one. So we're going to be taking here. because you want it to be the alpha carbon with the nitrogen, if that makes sense. I'm going to use my heterolytic function to deprotonate that oxygen and protonate the nitrogen. Okay, now I'm going to roll things around. I want L, so I want to make sure that my nitrogen is on the left side once I have both the nitrogen and the hydrogen facing towards me. It is on the left side, so that should be good. And there's no chiral centers, just as the last one, because we've got, did we draw aspartic acid on the last one? Or we drew asparagine? Okay, nonetheless, we don't have a chiral center, another one, so we can leave it. I think when we have a chiral center, another one, we want to make sure it's opposite of this. So if this is R, we want to make sure it's S. Or at least if you have like that paper, you want to make sure if this group is on this side and OH group needs to be on this side, make sure it's on this side. So I am just going to submit it. I think I already did everything I needed to do to make sure that it was good. Okay, yeah. Okay, so that's this one. I will try to make the other ones. I'm trying to do it on my downtime, but I don't get much of that. But yeah, good luck. This should be easy. And again, I will link that URL down below, and it'll, trust me, you'll fly through this. Just keep an eye on your D's and your L's. And yeah, good luck.